in a spring loaded of the governor of the Hartnell type. The lengths of the horizontal and the vertical arms of the bell crank lever are 40 mm and 80 mm respectively. Full point. The mass of each ball is the mass of each ball is 1.2 kg, 1.2 kg. The extreme radii of rotation of the balls are 70 mm and 105 mm and 105 mm. The distance of the fulcrum of each bell crank lever is 75 mm from the axis of the governor. Someone should say now. Axis of the governor. Okay. Full point. The minimum equilibrium speed is 420 rpm and the maximum equilibrium speed 4% higher than this. Full point. Neglecting obliquity of the arms determine the spring stiffness initial compression and equilibrium speed corresponding to radius of rotation of 95 mm. Okay. So you note down all parameters first. You note down all given data. Okay, first let us draw the diagram. First, let us draw the diagram. Otherwise, you note down first given data. Okay, now bell crank lever 40 mm is horizontal, 8 mm is vertical. Okay, and small m is 1.2, R1 is 70 mm, R2 is 105 mm. Okay, so distance of fulcrum to the axis of rotation is 75. Okay, so now minimum equilibrium speed is 420 rpm, maximum equilibrium speed is 4% higher than this one. Okay. Now we need to find out what is the S and what is the delta 1, that is what is initial compression, and you need to calculate equilibrium speed for rotation of 95 mm. Okay, for rotation of 95 mm. So first note down given data here. Okay, now according to diagram, okay, so according to diagram, so B is horizontal arm length, it is a 40 mm here. Okay, so A is vertical length, it is 60 mm. Okay, so small m is 1.2 kg. Okay, and rotation of ball R1 equal to 70 mm and R2 equal to 105 mm. Okay, and distance of fulcrum to the axis of rotation, let us take this as x dash, it is of 75 mm. Okay, and minimum speed, so n1 is how much, 420 rpm. Okay, so n2 is 4 percentage higher than n1. Okay, n1, so you need to calculate what is the value of s, initial compression, and one more speed, n3. Okay, n3. Now shall you go for solution? Okay, now first let us draw the diagram. So if you draw the diagram, so it is very clear to solve the unknown parameters. Okay, so now let's go for first position. Okay, so now this is what R1. Okay, so now this distance is here, it is x dash, it is 75 mm. Okay, R1 is 70 mm here. Okay, so next go for second case. Now this is what R2. Now this distance is x dash, it is 75 mm. Okay. Now this is what 105 mm. 105 mm. This is 70 mm. Okay. So now let us go for solution here. Let us go for solution. So first you need to find out what is the stiffness here. What is the stiffness? So stiffness is equal to 2 in bracket a by b square, okay, in bracket f2 minus f1 divided by r2 minus r1, right? So now f1 is the initial centrifugal force, okay. F1 is what? Initial centrifugal force. So now let us find out centrifugal force at radius r1. Now this is what? m1 omega 1 square into r1. What is the angular velocity? Omega 1 is equal to 2 pi n1 divided by 60. Now 2 pi n1 is 420 here, okay, 420 divided by 60. Now we calculate what is omega 1 here. Whether it is 44 radians. Forty-four radians ಬರ್ತಾ? How much you got to answer? Am I audible or not?
ಎಸ್ ಸರ್ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿ.
ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿದಲ್ಲೋ. So mass is 1.
43.9.
Okay, so 44. 1.2 into 44 square. Now R1 is 70. Let us go for 0.07 meter. Now we find out F1. How much F1? मांगे
436.8.
436 F1
N2 sir.
162.62.
162.62 Newton. Okay. Now what is the value of N2?
436.8.
So now find out omega 2. How much you got omega 2?
2.74. 45/74.
Okay. So now you find out F2, centrifugal force for maximum speed or at a maximum speed. So now calculate what is F2.
Two 63.6.
Okay. So now find out what is the spring stiffness here. So S equal to, so 2 into, so A is how much A? A is 60 mm here. Okay, 60 divided by 40, this square. Okay, into F2 is 263.26 minus F1 is 162.62 divided by 105.07. So now you find out stiffness. Now you have substituted values in terms of meter here. Okay, here you have substituted m because it is a ratio. Okay, because it is a ratio, it is a dimensionless parameter. You will get a constant value there. Okay, so now you find out what is the value of S. Now the value you are going to get here, it is of Newton per meter here. So now you can convert this one Newton per mm. Okay. So to convert Newton per mm, you just multiply by 1000 here. Otherwise, you substitute here only in terms of mm. Okay. Let us go for in terms of mm to avoid confusion. Okay, now you calculate what is the value of S.
$12.9, sir.
Now wait, what is the value of now A value is 80. Okay, so here A value is 80. We took a 60. Let it be. Okay, so you go for 60 only. Okay, how much you got? S equal to
12.9.
12.9. Okay, so 12.9 divided by 1.5. How much you are going to get here? Someone give the answer. Just cross verification.
8.6.
Okay, right. As it's a vector of square, let it be. Okay. Now it is over. Okay. So now you calculate what is the initial compression of the spring. Okay, so to get the initial compression of spring, so you need a spring force. Okay, you need spring force. Okay, so second bit is initial compression. Okay. So now, as you know, for equilibrium condition of the arms for maximum speed and a minimum speed. So now, as it is for minimum speed, so F1 into A equal to 1 by 2 in bracket mg plus fs1 plus f into b. Okay. Now this is a relation. So as you don't know value of sleeve mass and frictional force, you just neglect these two values and rewrite this equation. F1A equal to 1 by 2 fs1 into b. Now as you need to find out fs1, okay, as you need to find out fs1, so what is the relation here? 2 f1a divided by b. Now let us substitute the value here. 2 f1 is 162.62, a value is 60, b value is 40. How much you got a spring force?
487.86.
Okay. So now initial compression, you can say delta 1 equal to fs1 divided by s. Okay. So 487.46 divided by 12.9. Now you find out how much you're going to get the initial compression.
$37.8.
Okay, now 37.8 is initial compression of the spring. Okay. Next, what is the third bit? What is the third bit? Third bit. So you need to find out, okay, equilibrium speed. Speed corresponding to radius of rotation of 95 mm. Okay. So now as the radius is goes on changing, okay, so the centrifugal force is going to vary. Okay, the centrifugal force is going to vary. Now in this problem, so the constant parameters are here. So now constant parameters. Now spring stiffness is constant here. Okay, b is constant, a is constant. Okay, now what are the variable parameters? So now spring stiffness is constant, arm length in vertical direction as well as in horizontal direction is a constant. Now variable parameters are radius here. So as the radius is going to vary, the centrifugal force is automatically going to vary, right? Now if the radius increases, automatically the centrifugal force is going to change. Now you need to find out what is the centrifugal force you are going to get for the radius of 95 mm. Okay, for the radius of 95 mm. Once you got the centrifugal force, then use that centrifugal force and find out what is the angular velocity. Then based on angular velocity, you find out what is the speed. Okay, now it is just a reverse procedure. Okay, now so you know that, so the spring stiffness S equal to 2ab divided by a divided by b square. Okay, so f2 minus f1. Now let us go for f3 minus f1. Okay, so now here r3 minus r1. Now you can use f2 also. You can use f2 also. Okay, so it is going to give some appropriate results also. There is no any change because the spring stiffness is constant. Okay, the spring stiffness is constant. So now let us find out. So let us determine the centrifugal force F3 for radius r equal to 95 mm. Okay. Now we substitute all parameters here. S is 12.9. Okay. Now 2, A is 60, B is 40. It is a square. Okay. Into, now F3 is unknown. F1 is 162 point. How much it is? 162.62. Okay, so divided by R3 is 95, R1 is 70. Okay, so now you calculate what is the value of F3. So someone calculate quickly. Twelve point nine into 25 equal to 1.5 square F3 minus 162.62. Okay, so now F3 equal to 112.9 into 25 divided by 1.5 square plus 162.62.
234.12, sir.
Okay, 234.12. Change button nodo.
305.9, sir.
305.9. What is the value of F2 for radius of 105 mm? How much you got F2? F2. How much you got F2? 263.26. It should be within a range. Okay, it should be within a range. Okay, so now 234.12, I think it is a correct answer. Okay, 234.12, I think it is a correct answer, right? Now, so speed, okay, N3. Now you know that centrifugal force F3 equal to what? M omega 3 square into R3, right? So now let us substitute 1.2 omega 3 square is unknown. Now radius is 0.095. F3 is how much? 234.12. 1.2 omega 3 square 0.095. Now omega 3 square equal to, now simplify, how much you are going to get omega 3 square? How much you got of omega 3?
45.3.
45.3.
3.
Now you find out N3.
432.5.
432.5. 432.5. Right. 432.5 RPM. And now just keep in mind that now as you go to N3 is less than N2. Okay. Now you just observe here. For R1 equal to 70 mm, so speed is how much? So N1 is 420 RPM, right? So R2 equal to 105, speed is around 436.28. Now as the radius is in between these two values, now this hint will give some idea to cross check your answer whether you got the answers are right or wrong. Okay. Now R1 70, N1 420, R2 105, N2 is 436. Now as radius is less than 105 and more than 70, so now the N3 has to be in between these two values. Okay. Now you got a 432.5 RPM. I think this is the right answer. Now your N3 should not be in more than 440 RPM and not less than 420 RPM. Okay. You keep in mind. Now this way you can cross verify your answers. So there you got answers right or wrong. Okay. Right. So next to note down. Next to note down. In a spring loaded Hartnell type governor, the mass of each ball is 4 kg and the lift of the sleeve is 40 mm. The governor begins to float at 200 rpm when the radius of the path is 90 mm. Full point. The mean working speed of the governor is 16 times the range of speed when friction is neglected. Full point. The length of ball and roller arms of the bell crank lever are 100 mm and 80 mm respectively. Full point. The pivot, center, and the axis of rotation of governor are 115 mm apart. Full point. Determine the initial compression of the spring so into taking into account the obliquity of arms. Full point. Assuming the friction at the sleeve to be equivalent to a force of 25 Newton, determine the total alteration in speed before the sleeve begins. to move from the mid position. Okay. Everyone noted?
Sir, that.
So,
Yes, sir.
okay. So now actually this problem consists of mainly two portions. Okay. So one is calculation of the stiffness. Okay, as well as the speeds without considering the frictional force. Then you need to find out what is the alteration of the speeds if the sleeve begins to move from the mid position when it is under the action of frictional force. Okay, when it is under the action of frictional force, right? Now you need to find out what is the alteration in speeds. Suppose if you consider the frictional force. Clear? Now, as I said, it consists of two parts here. So now this portion is consideration of frictional force. So now what they have asked only the alteration in speed. Okay, only alteration in speed before the sleeve begins to move from its mid position, right? That means you need to find out what is the mean speed and maximum speed, okay? M1 and N2 from mid position. Okay? And above position, okay, so you need to find out here initial compression, okay, initial compression of the spring, okay, taking into account the obliquity. That means now we need to consider what is the inclinations are there, okay, what are the inclinations are there, okay. Now inclinations are to be calculated. So when you got the lift of the sleeve here, lift of the sleeve, okay. Now what is the total lift of the sleeve? It is a 40 mm. Okay. So from initial position to the final position, so lift of the sleeve here it is 40 mm, right? Now you need to draw the diagram carefully. Okay. So then you need to find out what are the initial speed and final speed. Okay. Now they have given so the relation between the initial speed, final speed, and the mean speed with some ratio here. Okay. Now the mean working speed of the governor is 16 times the range of the speed. Now you just okay. Now here you look at the sentence here. Mean working speed of the governor is 16 times the range of the speed. Okay, right? Now mean speed is equal to what? N1 plus N2. Okay, N1 plus N2. So now they have given N1 here. That is what begins to float. That means initial. That is what N1. Okay, N1 is given. Now based on these two relations, you need to find out N2. So when you got the N1 and N2, then you find out omega 1, omega 2. Next thing is you need to find out F1 and F2. Okay, so to find out the F1 and F2, you need the radius of rotation. Now in this problem, they have not given radius of rotation. Simply they have given what is the arm length for ball position, what is the arm length for roller position. Okay, but they have given pivot position here, but they are given pivot position. Now taking all these factors, you need to find out what is the radius of R1 and radius of R2. Once you got the radius of R1 and R2, so then you can find out the value of spring stiffness. You can find out value of spring stiffness, right? So you have a next class. Someone unmute and give the answer.
10, 10 15.
ನಾನೊಬ್ಬ ಹೆಸರು ಅಂತ ಆಲ್ರೆಡಿ 10-15 ಅಂತ ಒಬ್ಬ ಹೇಳ್ತಾನ, ಒಬ್ಬ ರೈತ ಅಂತ ಹೇಳ್ತಾನ. ಬರೆದಿದ್ದಾರೆ ಹುಡುಗರು. Okay, let us go for steps up to calculation of speeds. Okay, so further steps will continue in next class. Now let us find out what are the speeds here. Okay. So first you note down given data. Okay. Now mass of ball is 4 kg. Okay, lift of sleeve is 40 mm. Okay, so m1 is 4 kg. So let us go for h1 is a lift 40 mm. Okay, so next minimum speed is given n1 equal to 200 rpm. Okay, so next mean speed, so let us go for n equal to mean speed. It is equal to what? 16 times of average speed or range of speed. Okay, next, so ball and roller arms, ball is vertical distance, roller arm is horizontal distance. So now a equal to 100 mm, so b equal to 80 mm, right? Now pivot center of axis of rotations are 115 mm. So let us go for this as x dash equal to 115 mm. What else remains? Okay. So next they have given frictional force, it is 25 Newton. So frictional force 25 Newton. Okay. Now first thing is you need to draw the diagram, then only you can understand. So now you need to consider obliquity. Now based on that one, you will get the maximum radius and minimum radius. Okay. Now this is what axis of rotation. Okay. So now this is a fulcrum. Okay. So what is the distance here for fulcrum? Just drop here. Now this distance is x dash is 115 mm. Okay. Now let us note down this distance as A. Now this point as B and this point as C. This point as C. Now as it is going to lift a total distance of 40 mm. Okay. Total distance of 40 mm. So now let us assume it is going to lift 20 mm above and 20 mm below the mean position. Okay. That is what? From mean position. Okay. So now arm lengths are here. Now this distance is how much? 100 mm. Okay. Now this distance is 80 mm. Okay. Now let us go for, it is going to get the initial position for speed equal to n1 and for radius r1. Okay. So now this distance is what? It is a c1. Okay. This distance is a c1. So let us go for, this is what? h1 by 2. h1 by 2. So what is the total lift? Total lift is here, it is h1 equal to 40 mm. Okay. 40 mm. Now we are taking in an average. So it is going to move 20 mm upside, 20 mm downside. Okay. So now if you consider this is the initial position, okay, this is the initial position, that is what, R1 and N1, right? Okay, now this is one case. Now how much you took here? This is 20 mm. Okay. Now what about the second case? So for maximum speed, now for maximum speed, okay, let us draw it's a different color so I can easily understand. Now this is 20 mm. Okay. Now this distance is what? Let us take this as a C2. Okay. And radius of rotation here, it is what? R2. Okay. R2. Now you need to find out the value of C1 plus C2 and value of what you can say, uh, uh, okay, you need to find out C1 and C2. So if you got the value of C1 and C2, so you can find out value of R1 and R2, right? You can find out R1 and R2. So before that one, let us go for calculation of speeds here. Okay. So now let us start solution. So let us find out speeds n1 and n2. Okay. So n1 is given, it is 200 rpm. Now based on the relation, so if you consider n equal to mean speed, so now this is what, 16 times of range of speed. Now mean speed, how are you going to get? You are going to get n1 plus n2 divided by 2 is equal to 16 n2 minus n1. Now substitute 200, okay, plus n2 divided by 2 is equal to 16 n2 minus 200. Now let us find out n2 here. Let us find out n2. So now 32 n2 minus 32 into 200 minus 200. Now let us find out someone, what is the value of n2 you are going to get here? 32. Now this comes here. Now find out n2. Someone you give the answer n2. Yashwantra n2.
219.9, sir.
21.
9.9. So, sorry, sir. 212, sir. 212.9. Yes.
Okay. Now So we'll close here. Okay, so we need to go for college. We'll continue tomorrow.